this equation with derivatives in it. The only ones we're going to look at, or the only ones we're going to solve, are ones that are separable, which means you can get all the x's on one side and all the y's on the other. So for example, let's say I have dy dx is equal to xy squared. I can get the y's on the left and the x's on the right. So I'll have y to the negative 2 dy is equal to x dx. Now the dx's and the dy's, they must be on top. Otherwise it doesn't make any sense. So now I can integrate both sides because I've separated them. Y to the negative 2 becomes y to the negative 1 divided by negative 1 equals, the integral of x is x squared over 2 plus some arbitrary constant c. Now we can keep solving for my variable y. This is really, let's see, 1 over negative 1 over y, which is x squared over 2 plus c. So if I wanted to solve for y, I would have y equals x squared over 2 plus c on the bottom and negative 1 on top. I also don't really like that 2 down there. It kind of looks messy. So I'm going to multiply by 2 over 2. So I'll get y is equal to negative 2 over x squared plus, well, 2 times an arbitrary c is still going to be arbitrary, so I'm going to leave that as c. So that is my general solution. And if that's all the information I had, then I'm done. If, however, they said, oh, by the way, you also know that y of, let's see, what did I have? Y of 3 is equal to 1. Then we can use that to figure out what c is. So let's plug that in. Y of 3 equals 1. So I have 1 is equal to negative 2 times 3 squared plus c. Cross multiply, I get 9 plus c is equal to negative 2. So c is negative 11. So my particular solution, given this, oops, I'm sorry. Try this again. So I cross multiplied, got 9 plus c equals negative 2, so c is negative 11. So my particular solution becomes y is equal to negative 2 over x squared minus 11. Okay, so let's try another one. Let's get all this straight out. Suppose I'm given that dl dt is equal to k times L squared times natural log of t. I'll put the k on the outside. And since we have dl dt, that means L and t are our variables. So this k is a constant, and I can't change it. So let's separate. Since it's a constant, it doesn't really matter what side it's on. I don't know why the focus is doing weird stuff. Sorry about that. Okay. Cross multiplying or separating. Y to the negative 2 over here. Sorry, y squared over here becomes y to, shit, let's try this again. L squared over here becomes L to the negative 2 over here. And on the right, I'm going to keep the k, and I have natural log of t dt. Now, quick point. We've integrated the natural log of t several times using by parts. And the integral of the natural log of t dt is equal to t natural log of t minus t plus some arbitrary c. I don't really want to do by parts here since we've done this one so many times. So, integrating both sides, I get L to the negative 1 over negative 1 equals, well, that's unfortunate, same thing, k times t natural log of t minus t plus c tacked on the end. So that would be our, oh no, we haven't really solved crap yet. Let's see, this is, one again, negative 1 over L. I get k t natural log of t minus t plus c. Flip and negate. I'll have L is equal to negative 1 over k times t natural log of t minus t plus c. All that's on the bottom. So this is my general solution. If I'm told, in addition to that, that, oh, by the way, L of 1 is equal to negative 1, I can continue to solve and figure out what my c is. So negative 1 is equal to negative 1 over k times negative 1, times positive 1, natural log of 1 minus 1 plus c. Now the natural log of 1 is 0, so I have negative 1. Negative 1 equals negative 1 over negative k plus c. So cross multiplying, I get k plus c is equal to, oh, I should keep that k minus c since I'm actually solving here. Gives me a negative 1, so c is equal to k plus 1. So go back. So my particular solution is L is equal to negative 1 over k times t, natural log of t, minus 1. No, it's not. It's, oh, did I screw this up all the way? No, I plugged it in. Up here. Minus t, and my c is k plus 1. So there is my particular solution. And that's how you do differential equations. We split them apart and we integrate both sides. If you can't split them apart, we can't do them yet. There's a whole class on how to do differential equations. And these are just the beginning ones. So hope you enjoyed it. That's differential equations.